Are you preparing for a senior Java developer interview with over a decade of experience? This video covers the most commonly asked Java interview questions tailored for professionals with 11+ years in the industry. 1. Explain the differences between HashMap, ConcurrentHashMap, and Hashtable. When would you use each? Answer. HashMap, not thread-safe, allows one null key and multiple null values. Good for single-threaded applications. Hashtable, thread-safe using synchronized methods. Performance bottleneck under contention. Legacy class. ConcurrentHashMap, thread-safe with better performance using segment locking, Java 7, or bucket-level locking, Java 8+. Use case. HashMap for non-concurrent use. ConcurrentHashMap for concurrent reads/writes. Avoid hashtable in new code. 2. How does Java handle memory management and garbage collection? Answer. Java uses automatic garbage collection to manage memory. The heap is divided into young generation, Eden plus survivor spaces, old generation, tenured, metaspace, for class metadata, GC algorithms, serial GC, parallel GC, CMS, G1GC, ZGC, Shenandoah, Java 11+. As a senior, you should understand tuning JVM options, identifying GC logs, and analyzing memory leaks using tools like Visual VM or Java Flight Recorder. 3. What is the Java Memory Model, JMM? How does it relate to volatile and synchronized? Answer. JMM defines how threads interact through memory and how changes by one thread become visible to others. Volatile ensures visibility and prevents instruction reordering. Synchronized provides mutual exclusion and visibility guarantees. You should understand happens before relationships. 4. Describe the differences between composition and inheritance. Which one is preferred and why? Answer. Inheritance is a relationship, tightly coupled. Composition has a relationship, more flexible, loosely coupled. Preferred composition is preferred due to better maintainability, encapsulation, and testability. Favor composition over inheritance, effective Java item number 18. 5. What are common Java performance bottlenecks and how do you resolve them? Answer. Inefficient algorithms or data structures. Excessive object creation, GC overhead. Blocking I/O or improper multithreading. Database latency, N+1 queries. Solutions. Use profiling tools, JFAR, JVisual VM. Optimize data structures. Minimize synchronization. Implement caching, e.g. caffeine, cache. Use thread pools correctly, executors, fork join pool. 6. What are the key principles of solid design in Java? Answer. S. Single responsibility principle. O. Open/closed principle. L. Liskov substitution principle. I. Interface segregation principle. D. Dependency inversion principle. Real-world example, designing a payment gateway interface where new payment methods can be added without modifying existing code. 7. How would you design a thread-safe singleton in Java? Answer. Eager initialization. Lazy initialization with double-checked locking. Enum singleton best practice. 8. Explain how Java streams work under the hood. How does lazy evaluation benefit performance? Answer. Streams are built on internal iteration using splitterator. Intermediate operations map, filter are lazy, they don't execute until a terminal operation collect, reduce is called. Benefits. Reduces overhead by short-circuiting, e.g. find first. Enables parallel execution with parallel stream. 9. What's the difference between checked and unchecked exceptions? When should each be used? Answer. Checked exceptions, subclass of exception. Must be handled or declared. Used for recoverable conditions, e.g. I/O exception. Unchecked exceptions, subclass of runtime exception. Used for programming errors, e.g. null pointer exception, illegal argument exception. Best practice. Use unchecked for logic errors, checked for expected but rare conditions. 10. How would you implement a custom annotation and process it using reflection? Answer. At retention policy.runtime. At target element type.method. Public at interface myAnnotation. String value I. Processing. For method myClass.class.getDeclared methods. If method.isAnnotation present, myAnnotation.class. MyAnnotation and equals method.getAnnotation, myAnnotation.class. System.out.println and value I. Use cases. Custom logging. Validation frameworks. Runtime behavior modification.